Hello guys, this question is taken from International A-Levels C3 January 2016 paper, and this is a trigonometric question. 6 marks in total. Let's have a go at it. So first thing, for 1 mark, it has to be pretty straightforward. Show that the first equation is expressed into the this form here. So I'm going to start with the solution here. So first, part A, cot square x minus cosec x minus 11 equal to 0. So we know we need to find an identity which turns cosec or cot into cosec. If you're not sure about identity or you've forgotten, I would suggest start with the basic identity, which is sine square x plus cos square x equals 1. And you are looking for cot. Cot you can only get if you divide cos by sine. So if I divide by sine square x and divide by sine square x and divide by sine square x, you can see that cancels off, and you have 1 here plus that is cot square x, and 1 over sine is cosec square x. And we can now rearrange to work out cot square x is equal to cosec square x minus 1. So we can use that now. It might take a minute or two, but we are sure now we can use that. So instead of cot, I'm going to replace that by cosec square x minus 1 minus rest is exactly the same, cosec x minus 11 equals 0. So you can see minus 1 here, minus 1 and minus 11 can be combined. So my answer is now cosec square x minus cosec x, it will be minus 12 equals 0. So that is enough for 1 mark. Now for part B here, we have a limits given here 0 to 360, and we need to give the solution to 1 decimal place of this. So if we start from the same question, which is cosec. So if I start from that, which is cot square x minus cosec x minus 11 equals 0, and we already know that this can be written as cosec square x minus cosec x minus 12 equals 0. So which looks like a quadratic equation. So if you are happy using cosec, that's fine. If you don't want to use the trigonometry, you can always substitute and say let cosec x equals to, let's give some letter, let's say y. So this equation now changes to y squared minus y minus 12 equal to 0. Some students find that easier to work with. So let's factorize it. 12, 6, 2, 3 and 4. So I think we need minus 1, so I'm happy to use 3 and 4 there. So minus 4 minus plus 3, that works fine. So which will eventually give me y equals 4 and y equals minus 3. So don't forget to put it back. Now we said initially cosec, so I can say now cosec x is equal to 4 and cosec x equals minus 3. We know that cosec is written as 1 over sine x is equal to 4. Same here, 1 over sine x is equal to negative 3. We can do the reciprocal of both. will end up with sine x is equal to a quarter and sine x is equal to minus third. Now to work out the value of x, we need to do the inverse of sine. To work out the value of x, we need to do the inverse of a third. So here, just use your calculator. So shift sine inverse quarter gives me 14 point. So my x value is equal to 14.48. That's the first one. And if I use the other one, which gives me negative 19.47. Right, now look back into the limits. Limits was 0 to 360. So I'm going to use the cast method here. We know that how it works. So cosec sine is in the first one and in the second one. So this angle we know is 14.48. So this one will be 180 take away 14.48, which gives us 165.52. To work out the next angle, I need to go all the way around, and I can say 360 plus that, so which is beyond our limit. Our limit is only up to 360, so these two are the answers. Let's look at this one here. Same here, I'm going to do the 180 take away the previous angle. So 180 take away 19.47, which gives me 199.47. To work out the next, it will be 360 360 add 300 because it's going beyond. So add negative 19.47. So we may get a solution out of that. 19.47, which is 340.53. So now we have that solution, and this solution, whereas this one here is out of our range because it is less than 0. So there are the 4 solutions. So yeah, so if you liked it, don't forget to hit subscribe. Thank you.